Hello friends, welcome to my channel MathAlcoholic. So this video is going to be the concluding video of exercise 2.2 based on inverse trigonometric functions of class 12 NCERT Mathematics. So here I'll be discussing from question number 16 to 21st. Now in the questions 16th, 17th and 18th we are given to find the values of each of the expression. Now for this, if I remind you that we need to be very clear with this the inverse trigonometric table where the domains and range of each of the trigonometric functions are given. Okay, so basically you need to be acquainted with this at first, and we need to remember that all the values will be lying in the principal range. Okay, all the values of inverse trigonometric functions should lie in the principal range. Now keeping that in mind, let us start from question number 16. Okay, so question number 16 states that we need to find the value of sine inverse of sine 2 pi by 3. Now let us write it in one method and we will be doing the next problem in another method which is more comfortable. Now here it is an often very traditional method of writing. This is going to be sine inverse of sine pi minus pi by 3. Okay, why? Since 2 pi by 3 does not belong to minus pi by 2 to pi by 2, sine inverse sine 2 pi by 3 is not equal to 2 pi by 3. Well, many of you would be confused that why isn't it 2 pi by 3? Sine inverse of sine 2 pi by 3, why isn't it 2 pi by 3? But please remember that we always define sine inverse from minus pi by 2 to pi by 2. So if it has to be this, then this value, the sine inverse of sine x must lie between minus pi by 2 to pi by 2. But since 2 pi by 3 exceeds that, we need to find a similar value of sine x such that sine inverse of sine that x will be lying between minus pi by 2 to pi by 2. Since sine x is equal to sine pi minus x, we wrote it like this. So we can write 2 pi by 3 like this, and this very much turns up to be sine inverse of sine pi minus pi by 3 means pi minus x, and sine pi minus x is just x itself once again. Now we can say this sine inverse of sine pi by 3 to be pi by 3. Why? Since pi by 3 belongs to minus pi by 2 to pi by 2. Previously it did not belong to the principal value range, so we could not write it like that. Now it belongs. Okay, so this is the solution. Now coming to the 17th question. Quick. So in question number 17 we have tan inverse of tan 3 pi by 4. Alright, so we will be doing it in a very simple manner. Okay, now see, tan of 3 pi by 4, if you can remember from the graph that tan 3 pi by 4 comes out to be negative, and that is 3 times pi by 4. So we can also write it as tan inverse of tan pi minus pi by 4, and as you know tan pi minus x is equal to minus of tan x, so it is going to give me minus of tan pi by 4. Now what is tan pi by 4? 1. So tan inverse minus of tan pi by 4 means minus 1. Now see, we can write tan inverse of minus 1 as minus tan inverse of 1 very easily, and tan inverse of 1 comes out to be pi by 4 in its principal range, so the answer comes out to be minus pi by 4. Okay, so I guess it was pretty easy. This is a very competitive method of solving. We won't be taking too many steps either. We will be solving it in 2 to 3 steps. At maximum we will be taking 3 steps in case of competitive exam. In case of boards you can use either of the two methods, but you have to write it sufficiently. Now coming to the 18th question, we have tan of sine inverse 3 by 5 plus cot inverse 3 by 2. Now it is also a pretty easy catch. Now see, if we can somehow represent sine inverse by tan inverse and also cot inverse by tan inverse, so we get tan inverse x plus tan inverse x inside. So we can compound it, we can integrate it into a single formula where there is tan inverse only by tan inverse x plus tan inverse y, and then we can get tan of tan inverse. If you don't get what I say, please follow me. See, if we want to write sine inverse 3 by 5 in the form of tan inverse of something, we don't know what something is, so we can assume sine inverse 3 by 5 to be theta. That means sine theta is equal to 3 by 5. Now let us draw a right angle triangle with an angle theta such that sine theta is equal to 3 by 5. Okay, by Pythagoras theorem you will be finding the base as 4, so you can write tan theta to be 3 by 4, and that will be precisely giving you theta is equal to tan inverse 3 by 4. Alright, so we can write the same theta, which is equal to sine inverse 3 by 5, as tan inverse 3 by 4. Okay, so our sine inverse 3 by 5 comes out to be tan inverse 3 by 4. And similarly you can see that cot inverse 3 by 2 is exactly equal to tan inverse, just write the opposite ratio, 2 by 3. Okay, because cot inverse 3 by 2 is, let it be theta, so cot, this time let it be phi because we had already assumed theta. So cot phi is equal to 3 by 2, that means tan phi is equal to 2 by 3. It gives you phi is equal to tan inverse 2 by 3. So phi is the only thing, cot inverse 3 by 2 we had assumed, so it is going to give you tan inverse 2 by 3. So remember, sine inverse 3 by 5 we can write it as tan inverse 3 by 4, and cot inverse 3 by 2 we can write it as tan inverse 2 by 3. Alright, now we can integrate these two parts into a single tan inverse, and we know the formula very well, that is 3 by 4 plus 2 by 3 by 1 minus 3 by 4 into 2 by 3. So it is going to give me tan of tan inverse. Now what is it? This is going to give you 9 plus 8, that is 17, 17 by 12, 12, and here it is going to give you 17 by 6 finally. Now tan inverse 17 by 6 is clearly 17 by 6, and there are no constraints over it. Okay, so I guess this was pretty easy. Now coming to question number 19, we have to take note of a few facts. We are given to find cos inverse of cos 7 pi by 6. Now since it is an objective question, I'll be solving it objectively. Okay, now see, I'll be solving it in a bit different approach. See, I'm solving the same types of problems in different approaches. You can use any of the approach as you like. Okay, so see, cos inverse cos of 7 pi by 6, I'll be solving it in a graphical approach. As we know that the graph of cos x is like this. Okay, and it goes, this is pi by 2, this is 3 pi by 2, and here lies something pi. Okay, such that cos pi is the maximum value here, the minimum value, sorry, maximum value in the negative range. So this is minus 1. Alright, now 7 pi by 6, we can easily see that 7 pi by 6 is pi plus pi by 6, means pi plus pi by 6. Let us assume pi by 6 to be this much. So pi plus pi by 6 is going to be this value. Now cos inverse of anything is always defined from 0 to pi. So pi plus anything would not be a good option to give. Okay, so cos inverse of cos 7 pi by 6 will not be 7 pi by 6 at all, because it exceeds the principal range. So in order to bring it under the range, what we have to do, see, cos 7 pi by 6 is a ratio which is equal to this, which is equal to something like this. See, we can get the same ratio here also. Okay, we can get the same ratio here. Now this ratio, by symmetry we can say that this distance is same as pi by 6. So we can see pi plus pi by 6 gives the same value as pi minus pi by 6 here. Okay, so we can write cos 7 pi by 6 as cos of pi minus pi by 6 also, because both gives the same value by symmetry, and pi minus pi by 6 lies under 0 to pi, that is acceptable. So this is going to give you 5 pi by 6, and 5 pi by 6 is a well accepted answer as it lies in the range, principal range. So this is 5 pi by 6. Okay, and this is going to be the answer. Okay, now coming to this question also I'll be solving it in an easy method. See, sine of pi by 3 minus of sine inverse of minus half. So see, sine of, let pi by 3 be there as it is, sine inverse of minus half is simply minus pi by 6. Why? Because minus pi by 6 lies from minus pi by 2 to pi by 2, which is the primordial, or you may say which is the very primary range, principal range of sine inverse. So we can write sine inverse of minus half as minus pi by 6. Okay, now pi by 3 minus of minus pi by 6 will be giving you pi by 3 plus pi by 6, and pi by 3 plus pi by 6 is pi by 2. So it is sine pi by 2, which is equal to 1. Now coming to the last question of this exercise, similarly we have tan inverse root 3 minus cot inverse of minus root 3. Now let us check it out. So this is going to give me, see, tan inverse of root 3 minus of. You have studied that cot inverse of minus x is going to give you pi minus cot inverse of x, if you remember. So this is what I'm going to apply. So this is going to give me pi minus cot inverse of root 3. Alright. So this is going to give you tan inverse of root 3 minus pi plus cot inverse of root 3. Alright. Now tan inverse of root 3 plus cot inverse of root 3, you know it is pi by 2 very simply, and extra you have got minus pi here. So pi by 2 minus pi gives you minus pi by 2 here. So here minus pi by 2 turns out to be correct option. Okay, so it was pretty easy, friends. I hope you have no problem, and I hope from now onwards you will not have any problem solving this kind of problems. So this exercise we have gracefully completed, and if you have any kind of problem, please feel free to use the comment section. I'll be ready to help you as much as I can. And so we'll be meeting in the next video with the miscellaneous exercises, which is the last exercise, pretty not formal but last exercise of each of the chapters. And here it is, ITF, inverse trigonometric functions. Thank you for watching this video, guys. Bye bye.